This is Mr. Bornheimer, and I'm coming to you tonight just because I've recorded some videos for you to watch, and I hope that you'll find them very useful. As always, when you have video lessons and I'm not there to actually teach you, I want you guys to you can pause them, you can look at them. They're hosted on YouTube. You can watch them over and over again. But things that I do expect, first of all, that because they are video notes, they might not be as dynamic or exciting, and I apologize for that. However, they're still really important. So you need to take notes on them. Okay, so I will be expecting to see, or if I ask to see notes on the lessons that I've taught, I expect you to be able to provide those notes for me. Secondly, you should be able to use these videos to your advantage. I won't be reteaching these lessons in class, so if you, for whatever reason, didn't get the material, you need to go back on YouTube either at home or during study hall and watch the videos over again. Thirdly, please be mindful and respectful of those around you, because as always, videos can be distracting. You might be able to zip through the video and understand everything fine, but not everybody might understand everything exactly the same way you do. Okay? So, and some people might not get it right away and need to rewind. So please be respectful of where people are at and what people are doing as they kind of watch these videos and prepare um, to take notes and things like that. All right, so I'll be back as soon as I can. Otherwise, enjoy the video notes, and I hope you all have a wonderful day. Thanks for watching.
Hello, Pre-Algebra students. This is Mr. Bornheimer, and this is Lesson 2-7, Exponents and Powers. All right, here we go. The first example I want to talk to you today kind of demonstrates the different terminology or vocabulary that we need to associate with exponents and powers. So, let's look at an example. Here's a 4, and this 4 is going to be what we call our base number. And put the little word base right next to it. Okay, there's a couple reasons we call this a base number. First of all, when you think about a base, it's you have a base to a lamp. You have a base to a house. We call it a foundation. It's always the bottom. It's always everything that builds on top of it. Well, in exponents and powers, our base is our bottom number. It's the big number. Everything builds on top of it. So 4 is going to be our base. And up top, right there, and I'm going to just make that 4 red so we can kind of, 3 is going to be our exponent. That is a number that we can also kind of term as our multiplier. What does that mean? Well, that tells us how many times our base is being multiplied by itself. Okay, a multiplier or our exponent is kind of telling us how many times our base is being multiplied. Again, the idea of that multiplier by itself. All right, so this is what we're dealing with here. We've got a base, we've got an exponent, and so now we need to take a look at what does this mean. One of the best ways to kind of start to understand exponents is to start by writing them all out. See, exponents are a quick way of writing out long mathematical equations, representations. They help us to see what's happening, and if you can read them right, they're very useful. So let's go ahead and look at this. Let's say that I'm looking at that 4/3, or not 4/3, 4 raised to the third power. Well, 4 raised to the third power, if we think about what that vocabulary means, if we look, if we kind of think back to that definition, how many times the base is multiplied by itself. So I'll start with a base, and I'll multiply it by itself, and that exponent up top tells me that I'm going to multiply the base by itself 3 times. So there it is. These two things are the same. That's a really important distinction to make. They're written to be very similar. They both have a 4. The 4 appears 3 times. There's a number 3, okay, up here. But what you need to understand is that this is useful because it's a lot shorter. It takes a lot less writing, a lot less space. So when you're working with large equations as you get further and further in algebra and algebra 2 and geometry, this will become incredibly useful. They're both correct. They both equal the same thing. Okay, 4 times 4 is 16. Okay, 16 times 4, okay, would be 4 times 10 is 40, 4 times 6 is be 64. Okay, a little mental math there. So what we're looking at here is that they both have the same answer, but one is actually quite a bit more useful to us, especially as our math is going to progress and get more steadily difficult. So let's look at a couple more examples of how we can use this. And since this is pre-algebra, we're going to start to introduce ideas that involving letters. You probably have seen these exponent rules in previous courses. This is not a new idea to the 7th and 8th grade. However, that being said, it is still an idea that we need to explore, especially now with letters. So we're kind of transitioning into that algebra stage of exponents and powers. So let's go ahead and look at an example of what this might look like. Here we have 3 letters. X times X times A. And what I want you to do is I would want you to if you were given this problem on homework, I'd want you to write this in exponent form, okay, or in power form. Just so you know, the word power kind of implies exponent. They're almost interchangeable, okay? So if anywhere I see something repeated, I kind of count the number of times it repeats. Okay, so x is appearing not only once, but twice, and it's being multiplied by itself. This is the same thing as x here, which is our base, being multiplied by 2. Or not multiplied by 2, but being raised to the 2nd power. Okay, raised to the 2nd power. That's kind of the way we talk about it. What that means is that's x times x. So what we can do is then we can take and we can substitute that back in so that now it really is x squared times a. All I'm doing is I'm replacing multiples of something that is repeated with a base raised to a power. That's all I'm doing. All right, let's say you're given something like this. You have 3 times 3 times 2 times y times y times n times n. This is not an uncommon type of problem that you would see. And in your homework, you will see problems very similar to this. And again, this time around, we're asking you, what would this look like in exponent notation? So basically, you're taking anything that repeats, you're turning it into a base and an exponent, and writing it all out. Well, the very first thing I would recommend you do is identify your multiples, those numbers or letters that repeat more than once. So in this particular case, we're looking at these 3's. They repeat. The 2 doesn't, so I don't need to really worry myself with it. But the y's we repeat, and the n's repeat. So I can go ahead and write these now. 3 times 2, and let's not forget that that 3 is raised to a second power, because there was 3 times 3, there was only 2 of them, times y raised to the second power, because there was 2 of them, times n raised to the second power. Okay, so now we see that we have all of these numbers. And usually, typically when we finish our answer, we can write them so that they're kind of right next to each other. So I'll kind of show you what I mean, especially with letters. So we'll start with the thing that has the lowest power. Well, that would be 2. And just so you know, anything that is a whole number always has a power of 1. And if you think about my original definition of that exponent being a multiplier, well, 2, but it's only multiplying by 1 of itself, is really just 2. So now we write this as 3 squared times y squared. And one of the things you'll notice in algebra a lot is that they'll put letters next to each other without ever putting a multiplication symbol right here. What you should understand that this is indeed still multiplication. Y squared n squared is really y times n, which we see up here like so. Okay, this is what I would expect for a fairly right answer, or something very, very similar to it. I would also take this. Let's say you're given a number, okay, and it's already in exponent format, and you're asked to kind of expand it out. So let's go ahead and take a look at a number that already has an exponent. All right, here we go. -7 raised to the third power. Well, because the -7 is in parentheses, that means that I'm going to have -7 here multiplied by itself 3 times. So I go -7 times -7 times -7. What I should notice is that I have an odd number of negatives. So as we've already discussed in the past, that means I'm going to have a negative answer. So I'll put a little negative sign down here. Then we do 7 times 7 times 7. Well, 7 times 7 is 49 times 7. Okay, if we want to do some quick math, 7 times 9 is 63. Carry the 6. 7 times 4 is 28. Plus 6 is 34. So this is going to be 343. So there's our answer. And it's negative, which is what it should be. Okay, let's look at one more just to be sure. X times x times 3 times x times -7 times y. One thing you should do at the very beginning, again, and I want to repeat this, is that you need to identify those multiples. So go through and find the multiples. Well, we have this, this, and this. That's 3 x's multiplied by themselves eventually. So that's really going to be x to the third power. It doesn't matter that they're not next to each other. So long as they're all in the same line, you can count them. Then we go times 3 times -7 times y. Well, we can actually simplify these, so let's do it. We have x to the third times a -21 times y. Now we simplify it further. We start with the thing that has the lowest power. So it's y, x to the third times a negative 21. Another way that we write this oftentimes would be a negative 21 y x cubed. So this is just a little bit about exponents that I wanted you to look at. And a majority of your lesson is focused primarily on just observing exponents and working with them and trying to write them in exponent notation. Okay, looking ahead to your homework is dealing a lot with basically write using exponents, simplify different expressions using exponents. Okay, one thing that you do need to be careful of is because now that we're introducing the exponent, we're going to need to worry about order of operations. So let's look at one kind of mathematical expression. We'll simplify it, and then I think that'll be the end of our notes. So here we go. Let's say that we have a negative 3 plus 4 raised to the second power minus 4. Well, the first thing we do is when we think of PEMDAS is we do our parentheses. So this is going to end up being a negative 7 squared minus 4. Notice that this is, because of the way it is, that the negative is outside parentheses. It will not be included in raising the 7 to the second power because it's outside the parentheses. And whatever's in the parentheses and works with the exponent happens first before the negative is applied. So we really have a negative 7 times 7. That's the same thing as 7 raised to the second power minus 4. Well, 7 times 7 is 49, so really this is a negative 49 minus 4. We can think of this 49 minus 4, and this subtraction symbol right here can be thought of as adding the opposite. We can kind of change it a little bit. So really, it's the same thing as negative 49 plus a negative 4. So when we add those two negative numbers, we get a negative 53. So all of that equals that. I hope this helps answer some of your questions about exponents and whatnot. If you have any further questions about either your homework or the assignment or something that maybe is stumping you about exponents, please feel free to contact me using the B Classroom contact form. Thanks for watching, guys. Have a good day.